Welcome everybody. Good morning, good afternoon, good evening, wherever you are around the world. Welcome to the Materials Processing Institute in the United Kingdom. We are very excited to have you all on board and for your time today listening to us unpack and show you some of the capabilities of the new pilot arc furnace within the Green Steel Centre. Presenter team today, we have a message from our Chief Executive. You'll also be hearing from our Chief Technology Officer, Steel Plant Manager, and myself. I'm Mark Allen, and I front up the Green Steel Centre Business and Consultancy Unit at the Institute here. Please do remember to use the question and answer box. We're going to try and have about half the time talking and presenting, and then time for plenty of open questions, technical and general. We have the steel plant expert team on hand to answer. So also a note, please be aware this is being recorded. We'll endeavour then to share the video as soon as we can through mpiuk.com website. So a message from David. We are very excited and honoured to have your presence with us at today's official online launch of the latest investment in the Materials Processing Institute. This is a critical piece of investment for us in terms of our capabilities and for steelmaking around the world. As a standalone independent materials consultancy business, we are able to work with freedom of movement at any point in the steel supply chain, as well as with policy and consultancy parts of the business. So please enjoy this showcase of our new capabilities and expertise. The rest of this presentation is coming for me from the Green Steel team. Green Steel Centre itself, we set this up really as part of our core identity in terms of the mission of the Materials Processing Institute. We work with the steel industry and supply chain. It's about developing technologies, materials, the processes, but also the knowledge and skills to decarbonize steel production. And the key point here, this is about creating a sustainable, profitable green steel economy. We are in the business of commercializing technology. We're the last step in the chain between low technology readiness level, low TRL technology, and commercialization. And that's what makes us a critical and unique bit of capability within the global steel community, and particularly within the UK steel community, where, as you will be well aware, there's rapid transition towards a recycling, high recycled content, majority scrap-based economy, and transition towards a direction of movement whereby we're expecting 100% electrical steel making within the next decade. And how that works. The Steel Centre itself, Green Steel Centre, the work we do encompasses everything from green iron, the scrap quality, the arc furnace, the application of AI to all of this, and through to other downstream assets. And policy provision. There's a wide range of what we do, but what we wanted to focus on at this point is the electric arc furnace as the core piece of equipment that enables and strengthens and basically gives credibility at scale, at small industrial scale, medium scale, pilot scale, however you want to define it, but at ton scale. So we actually have realistic opportunities to work through all that hexagon of different benefits for the industry. The Materials Processing Institute are involved in and have been involved in a huge range of process and technology and materials development over many years. Bullet points here giving you just a walk through some of the programs and projects we've been involved in, whether that be in publicly funded, grant-funded programs, whether that be directly as commercial relationships with parts of the supply chain equipment developers, materials suppliers, and steelmakers. Grade development, continual casting, technical support, and process development, and ancillary materials development techniques. Very important in the transition to arc furnaces, techniques for nitrogen removal and minimizing nitrogen content in final steel grades. We're going to talk a little bit about opportunities now to improve our capability to do blending of ore-based metallics, HBI, DRI, and metal shot GPI as well. What we've done is we've created this furnace capability. We'll talk mainly about the hardware today. Is also make sure that it's plugged in digitally and we're capturing as many data points as we possibly can, and putting those into a machine learning model that enables us to use a human guided and human centered AI to accelerate experimental programs, but also to improve the reliability and confidence that we have in tying the data that we're getting from our furnaces to commercial operating furnaces, and have bespoke kind of data model matches going on as well. I'll talk through some of these other capabilities. We do everything from slag making through to assay, very mission critical assay melting. What we've done to enable that is to invest in this list of equipment here, which we'll be talking down through very soon, particularly the new Intico arc furnace with all those capabilities, Heraeus temperature scanning equipment. The roof of the furnace was also put in by the cast roof put in by Trent Refractories. There's been a real combined effort between us all over the last year and more of design to get to the delivery of the new arc furnace. And you may well have been watching us on video week by week as the capital production team has been talking through the different steps of pulling out the old works and completely renewing and replacing it step by step. However, enough of the pictures and the talk. We're going to cut now to some live video of the arc furnace in action. And
we've just finished the first commercial melt on our 7-ton electric arc furnace. But there's a few features on the furnace I'd like to point out to you. The first and principal reason why we actually bought the furnace is the use of this jet box. This jet box will allow us to inject oxygen and carbon simultaneously while we have the power on. The carbon and oxygen will mix in the slag and create a foaming slag. This is really important for the next generation of steels and slags, and a part of the research which is required to produce low nitrogen steels in electric arc furnaces. The jet box is also equipped with a natural gas burner, which will allow us to preheat scrap within the furnace and hence reduce our melt out times as well. Hence also then saving electrical power. We won't just have electrical heating from electrodes, we also have chemical heating as well now in this new furnace. Some of the other features I'd like to point out to you is the new slag door. The new slag door is hydraulically driven, and interestingly it doesn't have any refractory on the actual door itself. It is just a water-cooled steel plate. However, this new design of door allows us greater access to have a look at the arcs actually happening, and have a look at how foaming slag is occurring within the furnace when we're using the jet box. This new facility, it's a larger door, more vertically than horizontal, which then gives a greater field of vision. On the right, we have the carbon feed hopper for the jet box. And it's very simple to use really in terms of actually adding carbon into the melt when required. On my left, this is our new material feed hopper then. It is constructed so that it's capable of charging HBI, DRI, iron units or composite materials, a bit like these, then in through the fourth port, which goes directly in between all three electrodes from the furnace roof into the hottest part of the furnace. The work we do here on plant is supported by the metallurgical labs and the state-of-the-art equipment available to us here at the Institute. We can undertake metal analysis and slag analysis, which are live to allow us to undertake modifications to both the metal and the slag all the way through our melting program.
I'm Dr. William Knapp, the Chief Science Officer at Cocoon. Today at the MPI we are testing some prototype technology which we are hoping to integrate into our pilot plant in the southern US. We use the MPI for testing our technology because they have world-class facilities like the 7-ton electric arc furnace behind me, which allows us to test our technology at the medium scale. So there's small-scale technology testing and also obviously large-scale technology testing, such as that on a live steel plant. It's very difficult to find facilities where you can test at the ton scale, so subject our equipment to long durations of molten metal activities at that kind of medium scale, and the MPI is perfect for that level of prototyping.
This new furnace will allow the Institute to undertake the development of new steels and slags which will be required within the steel industry in this country and around the world.
Okay, hello, I'm Alan Scholes. I'm the Chief Technology Officer at the Materials Processing Institute. But in a previous role, I was responsible for the old pilot plant electric arc furnace at 6 to 7 ton scale. So I was very familiar with that, and I'm very excited to see how our capability has been enhanced by the new furnace. I'll start by saying something that sounds rather mundane amongst all the other enhancements, which was increasing the electrode pitch circle diameter has helped us tremendously, both in terms of getting a more even heating in the furnace, which gives us faster melting times, avoids a little bit of the cold bird nesting of scrap around the periphery of the furnace, but also having a greater electrode pitch circle diameter has given us more space to be able to situate the fourth hole in the furnace roof, which allows us greater scope for addition of continuous feeding materials and virgin iron units. So I'll say a little bit more about some of the new developments that we have put into the furnace. The whole package has been supplied by our Austrian delivery partner Intico, who have designed, built and installed most of this equipment. But one of the key features, which we did not have before, is the jet box, which allows us to introduce additional heat and chemical energy through the walls of the furnace. And through this jet box, we can either supply additional heat through a high velocity natural gas burner, but we can also inject carbon, which could be fossil fuel carbon, or it could be sustainable carbon in various forms, such as biochar, as well as oxygen injection. And what this allows us to do, which we didn't have the capability of doing on the previous version, is various aspects which will both improve furnace efficiency, allowing faster melting, scrap preheating, but also the injection of carbon gives us a lot more control over slag foaming, which improves both furnace efficiency in terms of its insulating capability, and also helps us with nitrogen control by preventing air ingress. And also the fact that we now have those as automated functions through the sidewall of the furnace means we can get away with some actions that had to be manually introduced in the previous furnace, where to do oxygen injection or carbon injection, we would have to stop the process, open the slag door, and introduce introduce lances through the open slag door. Another feature which is important for an R&D furnace is that we want to collect as much data as we possibly can. So continuous temperature measurement via the Heraeus Core Temp system sounds like a good idea from that point of view, but also from the point of view of practical furnace operation, it means we get away from the previous situation where we would have to stop to take temperature dips. And as an R&D based establishment, we would be taking more temperature dips than would be typical in a production environment, and that could have been adding a significant amount of time to our furnace operations. So reduced temperature loss, eliminating wasted time equals improvements in efficiency. The next key factor I want to talk about is the facility for us to continuously add material through the furnace roof during operations via the hopper and vibration feeding system that you can see depicted here. In terms of supporting the transition from traditional blast furnace steel making into electric arc furnace steel making, there are, as many of the people tuned into to this webinar will know, certain steel grades where, because of requirement for low residual element levels or low nitrogen levels, will require a proportion of virgin iron units to be blended in with the scrap-based mix, and this gives us the opportunity to do that. On the video, Tony described improvements to the slag door. Again, that doesn't sound immediately obvious, but the new slag door operates more quickly and more effectively than its predecessor, which means when we want to do things like observations on foaming slags, we are better able to do that with shorter and less intrusive delays to the main process. And one of the trends we've noticed in recent years is that, as well as work to develop and improve the steel making process, there is an increasing level of interest in use of slags as byproducts and adding value in the circular economy. So we find ourselves being called upon to do increasing amounts of work towards providing sustainable solutions for cement, roadstone, and other applications, where being able to tweak the slag analysis in the later stages of the process can be very important. Of course, the electric arc furnace is only one part of the steel making process, and in the Green Steel Centre, this is our first stage of emulating the typical process route for an electric arc furnace based steel maker. And of course, electric arc furnace steel making is followed by secondary refining and by casting. And so we have downstream capabilities that build upon the foundation of the electric arc furnace. So we have a secondary refining capability where the ladle of steel can be then moved into a tank, and in the refining station we have both ladle arc heating capability where we can alloy and stir and refine whilst maintaining temperature. But then when the tank moves under its close-fitting roof, we can then draw a vacuum and carry out vacuum refining activities, which allow us to make almost every steel grade we could be called upon to make, with some reservations over things like ultra low carbon stainless, but most steel grades that we could be called on to be made, we can make. And then, of course, having refined the steel, we have to be able to cast it. And here we have options of ingot casting, as depicted in this short video, or continuous casting, where we have a single strand caster, which is I have a single strand caster which is capable of producing either a small square section of 180 millimeters square or a rectangular mini slab section at 300 millimeters width by 140 thick. And with that combination of primary electric melting, secondary refining and casting, we have in place at research and scale-up level most of the tools required to emulate the typical production route for an electric arc furnace-based melt shop. Of course, not every melt is done at that scale, and we have other melting facilities, including induction melting, where at laboratory scale, the smallest thing we could melt is about the size of a baked bean, ranging up at the upper end to 1 ton induction melting open to atmosphere, or we also have a 100 kilogram vacuum induction melting facility, which tends to get used for some of the ultra high purity grade development work for customers such as the nuclear sector. And it's not only steel that we melt. The last thing I will describe is a top-blown rotary converter, a Caldo furnace, if you will, which is a rotary gas-fired furnace which we can run in either oxidizing or reducing mode. And we use that to do work such as fine techniques for recovery of valuable metals from steel mill dusts or other types of dust and waste. And at that point, I will hand back over to my colleague, Mark, who will wrap up the presentation.
Wonderful. Thank you, Alan, so much. We've given you a real run through, a quick run through. We could obviously spend hours talking about any of these particular facilities and projects. And if you book us to do some training for you, we will spend hours literally talking about every single detail of the process. But for now, we are open for business. Please get in touch with us, and we will be getting in touch with you as well. For any of these facilities, these options we have here, scrap blending and new steel grade production, analysis and commercial de-risking of potential new raw material streams, whether that's carbons, limes or other alloying agencies, transition to lower nitrogen steels with a higher recycled content, value from slag products, assaying, a commercially realistic and valuable ton scale of assay results, so you actually have statistically meaningful and commercially useful information. And also, of course, as Alan was pointing out, the facilities for casting bespoke chemistries of ingots and slab semi-finished products, if you then want to take that further to work on the final, the finished product of a new design line. And equipment trials, there is a lot of capability here to try out new equipment, to try out new refractories, to demonstrate and again help you to make the business cases for innovations within the supply chain. But thank you very much for your attention and time to listen to us. What we'll do now is take some questions and go live onto screen to do that. And I'm hoping there's a stack of questions waiting for us in the here we are. I'm hoping there's a stack of questions waiting for us in the Q&A box. Let's have a look. Here. while we're just waiting for this to load up, obviously, please follow us, like us, and share us on LinkedIn and so on as well. There's a lot of great videos on our LinkedIn and YouTube pages of the construction of that furnace coming along. I'm just adjusting my camera because I don't think you can see me. Right? Oh, that's fine.
I'll read out the questions.
Here we are. I'm on. Yeah.
You okay now, Mark?
So I'll start with some of the first questions. Do you currently have or envisage any shared or funded projects for this facility? And what would be my minimum training cohort, if any? I'll actually let Tony talk about that because he's one of our key master trainers. Here we go. Do we have any shared or funded projects for this facility? Yes, we're doing work at the moment, but what's our minimum training cohort?
So we do have these funded projects actually on this facility, and obviously we work with many clients actually around the world for this who have access to use our new facility. Then minimum training cohort really be essentially we'll be looking to do a bespoke training course then for the individuals, depending on the training requirements then for the individual clients that actually will deal with. So we tend to look at maybe anywhere from 2 days worth of training through to weeks worth of training, depending on exactly what the requirements would be. Okay. Next question.
What have we got next? I'll zip in and have a look here. A lot of the upgrades you showed, such as the roof feeding system, the core temperature measurement, and the improved slag door, seem to move the pilot furnace closer to full-scale EAF operation. From your experience, which of these upgrades has had the biggest impact in making the furnace behaviour more representative of an industrial EAF? And are there still areas where the pilot furnace is not yet fully representative of industrial operation? Well, one of the answers to that is get in touch with us and let's find out. Here's Alan.
Oh, okay. I'll take that one. In terms of helping the industry, whether it's the steel producers, whether it's the upstream or downstream suppliers, move in the direction that they want to, we felt that we have to have a facility that accurately mirrors the whole production process. And the furnace that we had before, which was a simple electric melter, allowed us to cover some aspects, but not every aspect. I suppose the single change amongst the many changes that we've implemented that pushes us closest to that emulation of the commercial production route is the secondary energy and the sidewall injection, because virtually every commercial arc furnace these days has that. So if we want to be able to say that we are collaborating, cooperating with them, working with them to do those sort of developments, we should be able to show that facility, and now we can. The increase in the electrode pitch circle diameter is helpful in practical ways for us in operating the furnace. The other key one is the roof feed, because the people transitioning from blast furnace to electric production in the coming years have significant challenges with those grades that require low residuals and low nitrogen. So I would say the combination of the sidewall injection and the ability to feed virgin iron units through the furnace roof are the two most significant changes. The other factors are important to us as enablers, but those are probably the two most significant changes.
Thanks, Alan. If I could add to the final bit of your question there, areas where the pilot furnace is not yet fully representative of industrial operation. One of the areas is on charge preheat. We can now preheat the scrap charge, which helps us with our energy balances as well. But we also, because we've been connecting up over the last year, training our team and training our machine learning systems, and we have an islanded kind of safe AI server, machine learning server on site here as well. It means we can look at operational furnace data from customers and also match up the correlations on ours to a much more exact extent rather than just kind of working out some fiddle factors. So that's something that quite excites me about going forward, how we can set the furnace potentially on different settings to match your own furnaces and more quickly have transferability of the results into what you'd be expecting in production. I think Alan wanted to add a little bit more on that question.
Yeah, there's just one thing I would add to that. If you ask where we are not going to be totally representative, it is going to be on giving precise figures for energy. The kilowatt hours per ton for a small furnace will always be inferior to a large furnace because we've got proportionally bigger surface area to volume ratios, we've got higher heat losses. So on those sort of questions, we will not tell you exactly what we think should be achievable in kilowatt hours per ton. What we can tell you is how one mode of operation is better or not better than another mode of operation. So in that sense, we give comparative answers. In things like steel quality and cleanness and what the process route should look like, we can give much more definitive answers.
Do you see a role for highly reactive lime or fine lime injection in future EAF operation, especially for faster slag formation or improved refining control?
Interesting question, that. I think certainly there will be, because obviously you are looking at speed of operation for industrial furnaces. Then, so the faster the process is, then the reduced amount of power that will be required and reduced amount of consumables, then therefore making steel and those four furnaces cheaper. So yeah, the faster the reactions, as long as they're controlled, then will certainly benefit overall EAF operation. And ultimately, on an industrial furnace, it's a tap-to-tap time that actually is the key figure, and that needs to reduce all the time to actually make steel plants as competitive as possible. Next one.
And as Alan said, we can benchmark different materials and different formulations of the same material to see how they compare one with another. Now that's actually it for the questions that I have dropped in here. There's a hand up on the screen as well. I'm not sure if we'll be able to get. I think Andrew, if DH has got the hand up, David Hogg has got his hand up. Hello, David. If you're able to, if you can be audible to Andrew with your question, if you haven't been able to put it in the Q&A, let's see if that can come through now. Oh, some more have just come up here as well. While we're waiting, is that coming through at all, Andrew? No. Okay. David Hogg, if you're able to type into the Q&A or into the chat, we'll endeavour to answer your question. In the meantime, how much of the available time is currently booked already? Question from Dean Cartwright. Hi, Dean.
Yeah, so at the moment in time, then we're working with a number of partners then and looking to pre-book the furnace for as much as possible throughout this coming year. Then at the moment in time, we're probably still doing some further work on the furnace, but we're looking at commissioning melts and further work melts for the next 2 to 3 months. I'm generally doing about, since we have to do all our research is undertaken from cold, then generally we look to actually do at least 2 melts per week. But then we're looking to be increasing that rapidly going forward throughout the summer months.
Yeah, so we have a forward order book going into this year, but we would like to increase that forward order book. It always gives us confidence and stability to be able to look forward through a whole year and to find the sweet spot where we're able to accommodate requests within a reasonable time frame. But also obviously to know we've got orders. Now it's possible through the Green Steel Centre, particularly if there's larger campaigns, to look at economies of scale, let's be honest, and bulk buy offers, or certainly to look at how longer campaigns and programs can get the best value for everybody. The point being, though, we're delivering the best value for you as well, and that is where the expertise that backs up the melt shop of the furnace is key in terms of what MPI offers the market, because there is they won't say it, they might get embarrassed, but the other two presenters with me today, there's an unparalleled level of expertise and experience, particularly in terms of design and delivery of effective experimental programs that give commercially viable results to customers. Not to mention training. There is space available. If you get in touch with us, we can fit you in for some melts during this spring and summer for sure. There's also at the moment space available within our training team to look at delivery, and that's quite an exciting opportunity to say that I would love to see the next generation of particularly UK steelmakers, but European and worldwide steelmakers, and a situation where every steel plant has got somebody who has come through MPI for steelmaking training, but has also learned not just how to handle an arc furnace production up close and personal, like we are able to do, but also to get their head around how do you utilize an R&D facility to answer questions? How do you work with that paradigm where, you know, if you have a production issue, that can be answered quickly and at a lot less cost than the loss of production by using our pilot facilities. So back to a slightly more precise question here. Could we say a little more about the carbon strategy box on our slide, please? Alan, would you like to talk a bit about carbon and biocarbons and?
Okay, carbon strategy. I guess that's probably a term that means slightly different things to different people. But my answer to the question will be around the capability of what we are set up and able to do, and how that fits into a wider carbon strategy. So as we know, there is strong pressure in the UK, in Europe, and throughout the world to reduce carbon footprint, and that manifests itself in the trend to transition from blast furnace to electric arc furnace steel making. And in the eyes of the politicians, that might appear like a simple answer to the entire problem, but obviously the problem is more complicated, because we know that in electric arc furnace steel making with 100% scrap melting, there are issues with certain steel grades, the issues of residual element contamination, the issues of nitrogen control. And although the electric arc furnace itself is an inherently lower carbon process, the role of carbon in steel making is an essential one. And in the electric arc furnace, it has become the norm around the world to have supplementary energy inputs, generally through the sidewall of the furnace, either fossil fueled burners or carbon injection systems with oxygen, which supply additional energy. And there are good process reasons for it. It makes the furnace more energy efficient in terms of energy units, in terms of processing time, but it's using carbon. And in the eyes of the complete purist, then that is beginning to compromise the green steel decarbonised argument, although it's still significantly below the levels of the blast furnace. So with our sidewall injection unit, we'll be looking not simply at carbon injection in the form of fossil fuels, but at sustainable carbon in the forms of biochar and other materials, which means that the carbon reporting of the carbon footprint can be brought down even lower. And also for the many technical people listening into this webinar, of course, you have to look at the process as a whole. So carbon used to create slag foaming the result of which is to better insulate the steel bath and to prevent nitrogen pickup, means less process energy used. Less process energy used if you work it back to whatever the power source is. It may be that the use of that carbon is more than compensated by the fact that the energy benefit is allowing a higher reduction of carbon elsewhere, either in the electricity supply or in better control of nitrogen, which means we can do things in shorter process times, less process steps. So it's very complicated to do the correct carbon footprint calculation, but we believe that with the modifications we're making or have made to the furnace now, we have the tools in our toolbox to be able to look at that full range of possibilities.
Thank you. I hope that was a comprehensive enough reply there. So my own research team, we also did quite a lot of work on green ions and alternative ion sources, and that's another area where carbon can enter the steel making mix. And there's a whole another world out. If you're interested in some one-to-one conversations or a larger bit of training or webinar package about that, get in touch with us, because again we could talk for hours about this. Unfortunately, we've now reached the end of our time slot for sharing. I would really like, if we've missed your questions, we will get back to you individually, and with your permission, then post the answers into the pack that will be available, kind of offline or online pack, but the post-event pack that we put together. Thank you very much for your attention. I do appreciate this, particularly colleagues around the world who may have got up or stayed up beyond normal working hours. I'll just leave you with really an invitation to stay in touch with us. The purpose of the Materials Processing Institute, the purpose of the Green Steel Centre, is to remain and to increase our importance in the development, the emergence, and the maintenance and the resilience of a greener steel sector that supports jobs, that supports advanced materials being produced, that supports the continuing advanced industrial economies that we find ourselves in, as well as industrializing economies. That's enough from me. It's enough from everybody. Many thanks to all of you. Thank you to the presenters. Thank you particularly to the media and events team who've helped put this on. Please get in touch with us, and we'll be talking to you soon. Very much hope. Thank you. End of it.